talk exponent rules and more specifically multiplication and division. So we're going to start off with multiplication. And the rule simply is if you have the same base, then you just add the exponents. So for instance, right here we have at the top, we have x to the a times x to the b. So in yellow here, that would equal, as far as the answer would be, x to the a plus b. All right, so let's take another example. So let's say we have x cubed times x squared. Our answer is simply going to be x to the 3 plus 2, which is going to equal x to the 5th. Now your base doesn't have to be a variable, it can be a number. Don't let that throw you. So let's say I have 2 cubed times 2 squared. Again, my answer is going to follow the same convention. I'm going to keep the base, and this time it's 2, and then my exponent is going to be 3 plus 2, so 2 to the 3 plus 2, and that equals 2 to the 5th power. All right, so the 2, our base is of 2 is low enough, and also the exponents are low enough that we could actually check the math here and kind of prove it to ourselves. So 2 cubed, let's see if we know how to work that out. So 2 times 2 is 4, that's 2 squared, times another 2 is 8, so that is 2 cubed. 8 is 2 cubed. So 2 cubed is 8, times 2 squared is 4. Okay, and so 8 times 4 is going to give me 32. So I need my answer to be 2/5, or that's the 2 to the 5th power. So that's the answer I got. So what is 2 to the 5th power? Oh, let's look. So 2 to the 3rd power, 2 cubed is 8. So 8 times another 2 is 16. That's actually 2 to the 4th power. And then times another 2 is going to be 32, and sure enough, that is 2 to the 5th power, okay? It's because that's 1, 2, 3, 4, 5 2's. So these two equal. We just proved that to ourselves. Okay, so that was multiplication. Let's talk division. So similar rule. So this case we have the same base again. You always need the same base, and you're just going to subtract the exponents. So x to the a divided by x to the b is simply x to the a minus b. All right, so let's say we have x to the 5th power divided by x cubed. So again, we're going to subtract the exponents here. We're going to keep the same base, x, and we're going to have x to the 5 minus 3, which is x to the 2nd power, or x squared. Again, that base can be a number, so let's say 2 to the 5th power divided by 2 cubed, all right? And so my answer is going to be that same base, 2 here in this case, to the 5 minus 3, or 2 squared, which we know, let's go ahead and say that's 4. So again, my exponents and my base are small enough to where I can check it. So let's check this 2 to the 5th over 2 cubed. So we already know, let's say 2 to the 5th over 2 cubed, that 2 to the 5th, we just found out that's 32. And we also know that 2 cubed is 8, okay? We know that now. So what's 32 divided by 8? Oh, it's 4. Dun, dun. That's right, okay? We've proven it. So those are the basic rules for multiplying and dividing bases with different exponents. So if you're have the same base and you're multiplying, then it's adding the exponents. Again, you have the same base, and you're dividing, then you're subtracting the exponents. So that's your foundation, and we'll build from there.